6.1, similar polygons. Everybody has this. We're looking at all you. You ready with calculators, pens, and paper? Let's go across this. This will be better for you because you learn better when we learn as a group. So, let's read this here. Two figures are similar if they have the same shape but are different sizes. We'll see in a second. A diagram drawn to scale to another diagram creates a similar figure. Likewise, an enlargement of a photo when reproduced to scale yields similar figures. For two figures to be similar, you need corresponding angles, must be the same size, and corresponding sides must be in the same proportion. They don't have to be the same, but they have to be the same. I'm going to hide this here. Okay. Now, what do we mean here? Well, that means, look at this. If I had this shape here, and then I duplicated this, but I made it a little. Do you guys see how this shape and the other shape are similar? If you follow what I'm saying, they have the exact same angles. This one's just maybe twice as big, approximately, the bigger one, right? So this shape is similar to that shape. The angles are the same. It's just if we do a ratio, one will be two times bigger and stuff like that. So all the measurements will just double. Hi there. I'm just recording this here, but I'll get this. You're here right now, Janelle. So, continuing on. Tara has drawn a scale diagram of a room. This is where the work begins. Alyssa, you'd be wise to get that 6.1 sheet from the box there. This is what we're doing. You don't have to. You can grab it. Now, scale diagram of her bedroom so she can sketch a different arrangement of her furniture. So anytime you see like blueprints for something, or if you're in a carpentry class and you see plans for something you're going to build, they're not going to make it, you know, huge drawing. They're going to make it so it fits on the paper, and that's a scale diagram. Everything will be proportional. So it's going to be the same scales we've been using all the time. On her diagram, the walls have the following length. So 8.5 double tick mark means inches, 3.4 inches, etc., 2 inches. Well, look at this. If the longest room is 12.75 feet, how long are her other walls? Well, let's just label on the diagram here. This is in real life 12.75 feet. That's a single tick mark. Jot that down. That's what we're going to use to solve all the others. Okay? So, for example, that's definitely the longest. Yep. So if we know that 12.75 feet is the same as 8.5 inches on the diagram, grab a 6.1. This is just what we're starting with. We're going to use proportional reasoning to do this. Here it is, man. Remember how we finished up? This is where we're at. So, jotting down. So how do we go about doing this? Well, the longest wall in the room is, okay. We're going to solve for all the other sides. So let's start with B. Makes sense to go with B, 6 inches, and then C, and then D, E, F. We use this fact here as a fraction to solve all the other problems. This is the same as the other units. We create a fraction that we can use to solve the problem. So we're going to say 12.75 feet. So I'm going to solve for B here. 12.75 feet is the same as 8.5 inches. What is that in the case of B? Well, B is 6 inches on the diagram. Where does that go, top or bottom? Because we're matching feet on the top, inches on the bottom on the left, so what do we do on the right? Inches from the diagram, where does that go? On the bottom. If we have inches on the left, on the bottom, we get inches on the, there. So we're going to get the real life B. Maybe I'll use a capital B to show that it's the big root B. Right? You guys know how to solve this too, don't you? You got calculators. I'll give you a second to solve that. Okay. Someone's going to tell me the answer. Who's the first one with the correct answer?
9.
Oh, you get it, Misha. How'd this for you? Let's say I never give her anything, eh? Okay, B. When you cross multiply, divide by the loner. The real life length of B, the wall B, would be 9. But 9 what? Feet, because it's across from the feet side. The top is in feet. So B is 9 feet. How do we go about solving for C then? I think it's about the same thing here. I'll do C right below it. What do we put on the left for any of these? It's the same ratio for every one of these, same proportion. We say 12.75 feet is 8.5 inches. 12.75 feet, that's from the given information, 8.5 inches. On this side, you guys set up what we do for C. Very similar to there. Side C. Tori, you know what you're doing with this one? The setup, exact same as the B one, except we're talking about side C, which I've underlined green. I'm going to use a capital C. We're talking about the big boy.
9.75.
Wow. I'm out of treats for this, but you must have put C on the top because that's with feet. 6.5 inches on the bottom. Okay. Then D, E, F, it's more of the same. You said you got 9.75. That's good. That's what you should get.
9.75 feet.
Feet. You even, what a treat. You know your stuff. Okay, then D, it's more of the same, isn't it? Tell you what though, we can come back to that. It's the same setup for D, E, and F. I want to just show you guys a couple more things. And you can finish D, E, and F afterwards, okay? Example 2. So flip the page. I know Misha's on a roll here, but we'll get to the next side here. Okay, look at this. The triangle, if you see that little sign, that triangle RST. Hi, Miss Davidson. RST, okay. Is given like this. And they were told it's similar to LMN. So that's this triangle. Do you notice that? The order is important. Angle R is similar to angle L. That's the first one listed, hey? Angle R and L. They look the same, don't they? The angles do, not the lengths. And then the middle one, S and M. Oh, yeah, it looks like S and M are similar. That's the way they're labeled. And then T and N are the last ones in the name, right? And T. Those are the same angles. That's what this is telling you. So, what are the angle measures of RST? So do you guys get the idea here? Just even take a look. Now I'll do a rough sketch here. Freehand. I trace it. Look at this. Sure, it's smaller than the other one, but you notice that this angle is the same there. This small angle M is the same, and the angle N is the same. That's what we're saying. Okay, now, don't need that, eh? Oh, I'll undo that. Okay, I'll lock that down. We're in lockdown. Okay. So, how do we solve this? If I'm told that angle L is 85 degrees, if I'm told that angle M is 78 degrees, and I'm told that angle N is 17 degrees. What are the measures of angle T, angle S, and angle R? Just by looking at the two diagrams, what's angle T going to be equal to? What's it like? This one's a non-calculator question. Brooklyn. What does angle T look like on the other diagram? It looks like the 17 on this diagram. And it is. We were, like I said, the T and the N match in the names. That means the angles will match. There's no calculations for similar figures if you have angles. They're just the same. They just are. The lengths differ, but so right here, I'm going to go angle T equals 17 degrees. It corresponds to angle N. Correspond means they're matching. So then angle S. Tori, which one does angle S match with? M. So therefore angle S, good, is the same, 78 degrees. This one's not designed to be tricky. And L and R match then. Angle R is equal to 85. Okay? It's just that we understand what's truly meant by similar figures. They have corresponding angles that are equal. They're congruent is the fancy word for this. Now the sides will be different. We don't have to figure that out here, but you know, the next kind of problem, stuff like that, we'll be working with sides. Now, example 3. We're all on example 3 now. Jason wants to build a model of his house. He'll build the model using a scale where 5 centimeters represents 2 meters. Okay. That's important because we got, when you see the word scale, that's the left side fraction. If one room is 6.5 meters long, 4.8 meters wide, and 2.8 meters tall, what will the dimensions be in the model? Hey, this is sort of like that first page problem. So, the scale model, he's going to build it maybe with popsicle sticks or something like that. Who knows? Tape and scissors and paper. Doesn't say what he's making it, but it's going to be small. Obviously, 5 centimeters representing 2 meters make it pretty small. So we're going to take what we underlined, and we'll say the room here, the model. We're going to find out what the model's lengths of everything is. I guess the model length. The model measurements, we'll say, for everything. Let's find them out. Well, we know that in the model, 5 centimeters is going to represent 2 meters from the real length in the room. And it's pretty obvious that centimeters should be the model, right? Well, let's do the length. I'm going to call L for 6.5 meters long. Now, where's the 6.5 meters from the 6.5 meters long rule? Top or bottom, Brooklyn? Bottom, because you're matching 2 meters in the real life room is 6.5 meters. We're going to call the top then L. You guys will know how to solve that, right? Let's just set up all the ratios and then you can solve afterwards.
16.25.
Or you could be really fast and do it right away. Wow, 16.25 centimeters. You are an all-star. How about this one? 4.8 meters wide. What do we put on the left? The exact same model scale. So we're going to put 5 centimeters. It's 2 meters. And then we're going to say the 4.8 meters matches the 2 meters. So, lady, you know how to find everything, I think. Help me find my keys next time they're missing. And then the last one, yeah, I'll do that one right here. 5 centimeters, 2 meters. All right. 0.8 meters. I can't work as fast as you. Tall, so I'm going to call that T. And you're going to solve them out. I think I heard you say, what did you say W was? In centimeters? Well, you already did it, but you didn't write it down. I'm sure you had the right answer. Anyways, this is the kind of stuff you're going to do on the next few questions. So you guys could solve those. So what you're going to do, finish this example, the DEF. Finish up these and then try these problems. Similar problems, there's some angle problems which are super cinchy. And a microscope thing, you'll get 2 answers. It was 12 centimeters, good. For the microscope one, the images are between 40 and 1600 times as big. So your scale will be 1 in real life to 1600 times larger, or 40. You'll have 2 to solve it. Okay? You'll multiply it with the 40 times magnification and 1600 times magnification. So go for it. We can arrange for more problems after that. I'm going to see how this recorded.